In this video, we'll look at the displacement reaction between zinc, chloride and magnesium. It's a redox reaction because one element is going to be reduced, one element is going to be oxidized. In displacement reactions, two metals compete for one other entity. In this case, it's the chloride. So straight away, I should be thinking chloride is my spectator ion because the metals are competing for the chloride. Chloride starts in a compound, it ends in a compound. It's my spectator ion. But hold on to your hat for that for now. So the simple equation, zinc forms 2+ ions, chloride is in group 7. So that means it's Cl-. So the formula for zinc chloride, ZnCl2. Magnesium is an element, so it exists as the atoms to form magnesium chloride. Again, magnesium is in group 2, it forms +2 ions. Chloride always forms -1, Cl-. So the formula for magnesium chloride, Mgcl2, and we've produced zinc, zinc being made of zinc atoms because it's the element. Now, busting out all of our ions, so our ionic compounds, we're going to bust them out to show the ions that are within them. So, like I just said a moment ago, we've got zinc 2+ ions, we've got chloride ions. How many chloride ions? We have 2 of them. That's reacting with magnesium to form magnesium ions, which, because magnesium is in group 2, are 2+, and chloride ions are Cl-, but there are 2 of them, and zinc atoms. Hey, like I said a moment ago, we know that these two metals are fighting over the chloride, so it's the chloride that will be my spectator ion, as proved by my all ions equation. There, chlorides have not changed in terms of their electrons. Nothing's happened to them. They were chloride ions before the reaction, they're chloride ions after the reaction. They are my spectator ions. Now we omit the spectator ions because actually chemically they haven't done anything, so whatever. All that's happening here is that magnesium and zinc are taking place in a redox reaction. So my ionic equation for this redox reaction shows what actually happened. Zinc ions react with magnesium atoms to form magnesium ions and zinc atoms. I've just omitted my spectator ions to show what's happening chemically. What has changed? Zinc ions have changed, magnesium atoms have changed. Now then, oxidation and reduction half equation. If you remember my little rule, reduction lower down. Whichever element is lower down the reactivity series. So in this case, zinc is lower down. So zinc is going to be my reduction half equation. So the half equation about zinc will be the reduction half equation, and the half equation about magnesium will be my oxidation half equation. So I'll just write down, I know that magnesium will be oxidized in this reaction because it's higher in the reactivity series, and I know that zinc ions will be reduced because zinc is lower in the reactivity series. Let's finish off these half equations. What happened to magnesium in this reaction? It went from being magnesium atoms to being magnesium ions. How does a magnesium atom produce a magnesium 2+ ion? It must have lost 2 electrons. Oxidation is loss. Ding, ding, ding. Yes, that is my oxidation half equation. Now I'll do my reduction half equation. What happened to zinc, my less reactive species, my less reactive element? It went to produce, so it changed from zinc ions to zinc atoms. How would zinc 2+ form zinc? It must have gained 2 electrons. Ding, ding, ding. Oxidation is loss, reduction is gain. Yes, yes. And the species that is lower in the reactivity series, so the element that's lower in the reactivity series, zinc, has been reduced. Lower, reduced. We can also double check to see that our ionic equation makes sense by actually adding together the 2 half equations. So let's have a little look at if I add them together. If I just write my arrow again, and I write down all of the species that I have in both of my half equations, are. So that's everything before the arrow in my two half equations. Now I'll write down everything after my arrow, after the arrows in the half equations. Good. Now, this is interesting. I have electrons before and after. They cancel. What's left? Magnesium reacting with zinc to make magnesium ions form and zinc atoms. Ding ding.